Good morning. This is Jennifer Martinez. Section 2.2, which is on page 32 of your class notes booklet, is on linear expressions. What is a linear expression? Well, if you remember, linear is going to mean a line. It's where the rate of change is going to be the same no matter which 2 points you pick. And when the rate of change is the same, it is called the slope, m. We also saw in the last section that linear expressions are of the form b plus mt, or if you'd rather, mx plus b. We have here expression, so I just took the right side of the equation, y equals mx plus b. So we saw m is the slope. B is going to be the y-intercept, or the initial amount, if you remember. So let's look at example 1. It says find the slope and use it to write formulas for each linear function. So let's start with the slope. So we know here m is the slope, which we know is the rate of change. So it's the change of y over the change of x, which is the rise over the run. There's also another formula if you need it, f of b minus f of a all over b minus a. So that's all the different ways to find the slope. So in this one, I'm going to use the rise over run idea, and I'm going to look at points that are right on the grid. So I'm going to start with this one. I think of the rise over the run, or the change of y over the change of x, I know that how much I rise from this point to this, and each one of these is 10, so I'm going to go up 10 and another 10, so I'm going to go up 20. 10 and another 10. And then how much do I run? This is how much I run. I run only 5 because this represents 5. So I go up 20 and I go over 5. The slope is 4. It's not the only way we could do it. We could use the second formula, or y2 minus y1 over x2 minus x1 if you'd rather. So those are all the formulas for the slope. So if you, like for instance, create a table here, I'm going to call this x and call my vertical y. I'm going to pick ones again that are grid. So this time's when x is 5, y is 10. And this one is when x is 10, y is 30. So I could also, or I could say, m is equal to the change of y's, or the f of b minus f of a, 30 minus 10, all over just the b minus a, 10 minus 5, just like we did in the last sections, which is the same thing. So this is a great visual. If you have a graph, you might not want to pick 2 points and subtract them. If you remember, this is a line, so the slope is the same no matter what 2 points you pick. So I could have picked these two. I could have picked, right? I picked B and C, but I could have picked A and B. I could have picked A and C. Any combination. So this one over here, notice how this answer for the first one, on the left, is positive and the slope is increasing. The one on the right here, it's going to be negative. The slope is going to be decreasing. So I'm going to go for the same easy method there. We can go for either one, but if I go for the rise over the run, or the change of y and the change of x, the rate of change, that is something that looks easily known. All the rest are kind of vague. This one is easily known. I would like to pick my points that are right on the grid, that I know exactly what they are. I'm going to start at 5, and I'm going to go down. So I'm going to go down 5, and then to the right 4. Oops. I said 4. So that would give me the slope of the second one. And notice how it is indeed negative. So I started from A and went to B. This is from A to B. It not only doesn't matter which 2 points you pick, because we know when they're linear, the slopes are going to be the same. It doesn't matter where you start. So if I wanted to start with the rise over run, starting with B, yeah, you would go up 5, wouldn't you? So, okay, I rise 5. But since we're up here at 5, then we're going to go left. Oh, we're running in a negative direction. So this would be negative 4. This is from B to A. And you notice that it's the same answer because a negative is a negative no matter whether it's in the numerator or the denominator. So now we're going to use this to write the formulas for each function. So now I'm going to use the form b plus mt or mx plus b. So let's go for the y equals mx plus b. And if you remember, b, this a little smaller, b is the y-intercept. So the y-intercept is like the initial condition. When I plug in a 0, I get a negative 10. So this one starts at negative 10. Or it's where it crosses the y-axis. So the b, in this case, is the y-intercept, or negative 10. That is the formula for b. So we know now that we can get the formula for this, for the linear function. So it's going to be the m, which we know, and the b. So you could say plus negative 10, or sometimes we just write 4x minus 10, since it means the same thing. And you can check it. If you plug in a 5 here, you get 20 minus 10. Plug in a 10, you get 40 minus 10. Plug in a 0, it'll all work. For the second one, to find the formula, you use the same formula up here. Guess I need to make this smaller even. So I'm going to do the y equals mx plus b. Same thing. We have the m. We're just looking for the b. So we know in this case, the b, for this one, the b is going to be 5. It crosses the y-axis at 5. Might as well give you square that. That's the formulas for the slope. And let's just go ahead and write that in. Negative 5/4 is what the m was. We'll keep the x plus 5. And you can check this one. You plug in a 0, you get 5. If you plug in a 4, the 4's cancel, and you'll get 0 with the 2 points they gave you there. So that is the formula for the second one, the slope and the formula. Okay, let's go and try example 2. Example 2 says the population of a town 2 years after it was founded is given by this formula. That is not our y equals mx plus b formula. This is going to be another form that we're going to learn in this section. It's going to be called the point slope form. Slope intercept form is what we saw up here. We should write that down. We'll write that down in a minute. But this up here was the slope intercept form. This is going to be the slope point form. And like I said, we'll see that in a minute. But right now, let's just find P of 5 and P of 6. So what is P of 5? P of 5 means I'm going to take this and I'm going to plug in 5. So I'm going to get 16,000 plus 400. Oh, what happens when I plug in a 5? That whole thing just goes away because that's 0. 400 times 0 is 0. So this would just be 16,000. So that's P of 5. P of 6 is 16,000 plus 400. Same formula, but now we plug in a 6. So that's going to be times 1. So that would be 16,000 plus 400. In this new form What does the t minus 5 represent? T minus 5 measures the number of years passed between year t, and year 5. So, for instance, when t was 6, the number of years passed between 6 and the 5 is 1 year, versus when t is 5, there is no years passed. What does the 400 times t minus 5 represent? It represents the change in the size of the population between year t and year 5. To see this, let's look at the units. The 400 is a slope, which would be the rate of change. So it would be the number of people per year. So there that is. So I'm looking for the units of the whole thing. And then the t minus 5, we just said that was the number of years. So I'm going to multiply that by years. And then the years would cancel. So the units would end up being the number of people. So it's the change. Again, another way to see this is if we look at the 6. We look at the 6, that means that we're going to change by 400. If you put in 7, that would be the change between 7 and 5, and so forth. Notice when t is larger than 5, it tells us how much the population has grown since 5 years. But if it was less than 5, then it would tell us how much smaller the population was compared to the year 5. So for instance, if t was 4, that would tell us the number of people after 4 years, which was a year before 5. I did forget to put the t minus 5 here, so we could just put it right here. So the units would be, let's change, and squeeze the t minus 5 where it belongs. So that would be that one. The slope-intercept form, I wrote up here, this is in slope-point form. We'll see that in a minute. That will be our next formula. Slope-intercept form is always the y equals mx plus b. So the y equals mx plus b is the slope-intercept form. Why is it called the slope-intercept form? Because here's the slope, and this is the intercept. So if we want to get it in the slope-intercept form, we just multiply that out. Let's go ahead and do that. So I'm going to take this formula, and I'm going to distribute that and get 400t minus 2,000. Then I'm going to subtract these and get 14,000. So you can see it's actually the population at t equals 0. That is the y-intercept, the initial amount. It tells us that initially, or when t was 0, the population was 14,000. To actually see the formula, let's move on to the next page. Point slope form. So here it is. F of x equals y naught plus m times x minus x naught.
The graph passes through the point x naught, y naught. These sub-zeros are just for a labeling device to let you know that it's initial condition, like x sub 1, x sub 2, or y sub 1, y sub 2 that we've seen before. The slope, aka the rate of change, is m. That hasn't changed. And here's an that you might have seen in other textbooks. So there it is. You can use f of x or y. Let's go ahead and try that. In this one, the x naught, y naught, this is, by the way, written as an ordered pair, is the x naught is 5 and the y naught is negative 8. And the slope is negative 3. So if I'm going to write what we would get, right, find linear functions with the following properties, we would get the negative 8, so that's the y naught. The m is 3, so I'm just going to write a minus 3. We leave the x alone, and the x naught. The one on the right, we do not have the slope, which is g of 8 minus g of 5. To find the function, you can use either leaving the xy alone x naught is the 5 and the y naught is the